Hello students, today we are going to learn gravitation chapter. This will be a second video of this chapter. In last video we have already studied till Kepler's laws. Now in this video we'll continue. Students, these Kepler's laws we did in last video. Kepler's first law, second law and third law. Full explanation is already given in last video, so we'll move ahead in this chapter. Here our next topic is universal law of gravitation. Newton's universal law of gravitation, students. Every object in the universe attracts every other object with definite force. This force is directly proportional to product of masses of two objects and inversely proportional to the square of the distance between them. I will explain you students how. See here, according to Newton, every object in this universe attracts every other object. So with the force, and this force is directly proportional to product of masses. Suppose there are two objects m1 and m2, then according to Newton they will attract each other. They will attract each other with the force F, and this F force will be directly proportional to product of masses and inversely proportional to the square of the distance between them. Square of the distance between them, d square, students. If d is the distance between them, then F is inversely proportional to d square. Here in this expression, when you will see, students, F is directly proportional to m1 m2, product of masses. m1 into m2 is in numerator, that means F is directly proportional to product of masses, and d square, square of the distance, is in denominator, so we'll say F is inversely proportional to d square. And when you will remove this proportionality sign, students, when you will remove this proportionality sign, we'll have to introduce a proportionality constant. Here the proportionality constant is capital G, and our formula will become, F is equal to G m1 m2 upon d square, students. F is equal to G m1 m2 upon d square. So this is the Newton's universal law of gravitation. Here, students, G is called universal gravitational constant, students. Here this G is a constant of proportionality. This is named as universal gravitational constant, and its value is 6.673 into 10 raised to minus 11 Newton meter square per kg square, students. Please remember this value. This value will be helpful for us when we are solving some, students. Our next topic in the same chapter is Earth's gravitational force. Now, gravitational potential energy. Here, students, F is equal to G m upon r square. In the last expression, whatever we got here, students, F is equal to G m1 m2 upon d square. Suppose one object is our Earth having mass capital M, and other object, instead of m2, any object is there which is on the Earth, students. I'll repeat in the same Newton's universal law of gravitation, which we did formula for this. Here in this, suppose we are having two objects. Out of these two objects, suppose one object is our Earth having mass capital M, and other object is any object which is there on Earth having mass M. So here, instead of m1 it will become capital M, and instead of m2 it will become small m. And suppose D, instead of D, the distance between objects, D can be represented by R. Here, because R is the distance between center of the Earth and surface of the Earth, the distance is capital R. R is the radius of Earth, students. I'll show you expression here. F is a force which is directly proportional to product of masses m1 m2. Instead of m1, m is a mass of earth, m2, m is any object which is on the earth, and r square is the distance, square of the distance between them. So here this is nothing but universal law of gravitation formula, students. So here in this expression, what I will do, students, we got Earth's gravitational force F is equal to G m upon r square. The Earth attracts every object near it towards itself with the force called the gravitational force. Gravitational force on any object due to the Earth is always directed towards the center of the earth. I'll repeat, gravitational force on any object due to the earth is always directed towards the center of the earth, students. Let's move ahead, students. Here, acceleration due to gravity, new subtopic is acceleration due to gravity. Here we have already studied, students, F is equal to G m upon r square, where m is the mass of earth, m is the mass of object which is there on earth, and r is the distance between the earth center and object. Here in our ninth standard, from second law of motion, since we have already studied F is equal to ma, mass into acceleration. Now when you will compare these two formulas, F is equal to G upon r square and F is equal to ma. When we'll compare, we'll see the left hand side of both the equation is same, it is F. So right hand side must be equal, students. That the same thing it is done here over here. So it is done G upon r square is equal to ma, students. Now what I will do here, students, when you will see both the side, small m is there, I'll just cancel small m from both the side, and our equation will be here, students, a is equal to G upon r square. Same thing is written over here, students. A is equal to Gm upon r square. M is constant, already cancelled, students. So here A is equal to Gm upon r square we got. Now here A is the acceleration, and this acceleration is due to gravity. So this A will be represented by G, and we'll get G is equal to Gm upon r square, students. We'll get G is equal to Gm upon r square, students. Now here, students, our next topic is variation in the value of G. Variation in the value of G. G is the acceleration due to gravity. Now, students, we have already studied that G is equal to Gm upon r square. G is equal to Gm upon r square, where m is the mass of earth and r is the distance between the object and earth. Here, students, capital G is constant, and it will not have any effect on G value. It will remain constant, students. So it will not affect the value of acceleration due to gravity, small g. This capital G is not going to affect small g, that is acceleration due to gravity, but m and r are going to affect. Here when you will see equation, students, G is equal to Gm upon r square. Capital M is in numerator, that means capital M is directly proportional to G. If M will increase, G will increase. At the same time, students, when you will see the equation, r is in denominator, so when r will increase, G will decrease. When r will increase, G value will decrease, and when r value will decrease, G value will increase, students. Now I'll explain you. Here we are going to learn variation in the value of G. First, we are going to talk about G at three conditions: when object is moving along the surface of earth. Second, we'll talk about when object is moving in upward direction away from earth's surface. And third, when the object will move towards the center of the earth, that is inside the earth, when object is moving inside the earth. So these three conditions we are going to discuss. We are going to start with first condition, when the object is moving along the surface of earth. Students, our earth is not completely spherical. Actual shape of our earth is shown here in this picture. Students, our earth is flattened at pole. It is little flat at pole and it bulges at equator. Students, at equator it bulges. Students, and at pole it is little flat, and this is the reason why the radius of earth is less at pole and is more at equator. I will repeat, students. Sorry, students. Here earth radius is minimum at pole and maximum at equator. Now I told you in the formula, G is equal to capital G capital M upon R square. Students, so G is inversely proportional to R. G is inversely proportional to R. That means when R will decrease, G will increase, and when R will increase, G will decrease. Inverse. Students, when here when R will decrease, G will increase. Students, when R will decrease, G will increase, and when R will increase, G will decrease. Students, here when you will move from pole to equator, the R value increases. That means G value will decrease, and the maximum value of G is at pole and minimum value of G is at equator. Maximum value of G is written over here. Students, at pole 9.832 meter per second square, and at the same time maximum value is 9.832 meter per second square, and the minimum value of G at equator is given by 9.78 meter per second square. Students, so you will remember, students, when we are moving from north or south, any pole to the equator, when you will move from pole to equator, when you will move from pole to equator, the G value decreases as R value increases. When we are moving from pole to equator, the radius increases and results into the decrease in G value. When you will move from pole to equator, students, R value increases and G value decreases. The maximum value of G is at pole and minimum value is at equator, and the values are 9.832 and 9.78. Students, let's move ahead. Now what about when object is moving away from earth surface? It is not moving on the earth surface. Suppose it is moving away, it is going in upward direction, then what? Now when it will move in upward direction, students, the distance between earth center and the object increases. The distance between earth surface and the object increases, students, and result of that, as R increases, G value decreases. Students, I explained you in last slide also, when G value R value increases, G value decreases, and when R value decreases, G value increases. Students, here when you will see, when the object is moving away from the earth surface, when the object is moving away from the earth surface, the R value increases. Students, R value increases, rises, and result of that, G value decreases. So students, you will remember, when object is moving away from the earth surface, the R value increases and G value decreases. Students, let's move ahead. Students, now third condition, when the object is moving inside the earth surface. Students, here, students, when we are talking about R is inversely proportional to G. When R increases, G decreases, and when R decreases, G increases. Students, now what about M? What about M? M is in numerator. Students, M is in numerator, When m increases, g also increases. M is directly proportional to g, students. Here m is directly proportional to g. When m increases, g also increases, and when m decreases, g also decreases, students. Here it is not like r. In r, what was happening here, students? I'll repeat for r also, students. Here, when r value decreases, g value increases. Here inverse relation is there, students. Here inverse relation is there between g and r. But when we'll talk about m, when m decreases, g value decreases, students. It is a direct relation. Whatever is happening with m, the same thing is happening with g. It is not an inverse relation, students. Now when we'll see that, suppose both m and m and r value both are changing, students. Suppose both values changes. Now what happens? Then in that case, m will affect more as compared to r, students. When both the values are changing, students, when m is changing alone, when m will increase, g will increase. If suppose r is changing, m is not changing, r will increase, g will decrease. But suppose both are changing together, both m and r values are changing together, in that case m will affect more as compared to r, students. And result of that, if m is increasing, g will also increase. Though r is decreasing or increasing, it will not affect, students. G will follow m. G will follow m here, students. I'll repeat again, students. If both m and g are changing, then g value will follow m value. If m increases, g will increase, and if m decreases, g will decrease. G will not follow r, students, if both m and g are m and r are changing, students. Now here we'll see what happens when any object is moving towards the center inside the earth. When object is moving towards the center of the earth the effective mass of earth changes, students. The remaining, suppose any object is moving towards the center of the earth, and suppose the object is here, students. Object is here, then for this object the earth is of this size only, students. The upper value will not be effective. The effective mass of the earth will remain of this size only, students. That means effective mass of the earth decreases. Effective mass of the earth decreases, students. What I said, students, when we are moving inside the earth, suppose we are reached till here, students, then the effective mass will be of this size only, students. Again it will decrease more. So as we are moving towards the center of the earth, effective mass of the earth decreases, students, and result of that, g value also decreases. G value also decreases, students. In third case, when the object is moving towards the center of the earth, m value decreases, and because of which the g value also decreases, students. This is about the variation in the value of g, students. Now here, gist of the whole, variation in the value of g. The value of g changes along the earth's surface. The value of g is maximum at the pole where it is minimum at equator, students. As we move away from the earth's surface, above the earth's surface, the value of g decreases. At infinite height, the value of g becomes 0, students. As we move inside the earth's surface, the value of g decreases, and at the center of the earth, the value of g becomes 0, students. So basically, when we are moving on the earth, surface of the earth, g value decreases from pole to equator, students. And when we are moving away from the earth surface, whether we will go up above the earth surface or inside the earth surface, as we move away from the earth surface, the g value decreases, students. So this is about variation in the value of g, students. Now here we are having next topic is free fall. What is free fall, students? An object is in free fall if it is accelerated due to the force of gravity and no other force are acting on it, students. If object is moving, performing any motion and this is due to the force of gravity. No other force is acting on it, then we will say the object is in free fall. The object is in free fall, students. Now for free fall, before we'll talk about free fall, students, we have already studied equation of motion in our 9th standard, students. We have already learned three equations of motion by Newton. V is equal to, first motion equation is V is equal to u plus at. Second, S is equal to ut plus half at square, and third is V square is equal to u square plus 2as, students. Here, students, for freely falling body from height h. Now here v is a final velocity, u is the initial velocity, a is the acceleration, and t is a time, students. S is a displacement. Now what I'll do, students, here S displacement is vertical displacement and will represent S by h, students. Will represent S by h. Here when any object is falling towards the earth, the initial velocity at the top, it should be 0, students. So I'll put 0 instead of initial velocity u. And acceleration, here acceleration, when any object is moving towards the earth, the acceleration, the body is getting accelerated because of the force of gravity. So a will be this a will be displaced by g. Instead of a, we'll use g, students. Now what will happen when s, instead of s we'll write h, when instead of u we'll write 0, and a is equal to g. We'll put u is equal to 0 later, student. First we'll put s is equal to h, and s is equal to h, and a is equal to g, students. Here our first equation, v is equal to u, instead of a we'll use g, students. We'll get v is equal to u plus gt. When we are using s is equal to h, we'll get h is equal to ut plus half a, instead of a we'll write g. We'll get gt square. Same, v square is equal to u square plus 2 gh. Instead of a, g, instead of s we'll write h. So this is our equation, students. Now in this equation, what I'll do, students, instead of u, when we'll put 0 value, our equation will become v is equal to gt, because the first term will become 0, students. At the same time, when you will put u is equal to 0 here, the first term will become 0, and we'll get g is equal to half gt square, students. Half gt square, and v square is equal to u square plus 2gh. Again first term will become 0, and we'll get v square is equal to u square plus 2gh. 2gh, students. So our equation changes like this. This is about free fall, students. Our next topic is derivation of Newton's inverse square law. In next lecture, when we'll start with the video, we'll start with this derivation of Newton's inverse law, square law, derivation for Newton's inverse square law. At present, I'll stop my lecture here only, students, and thank you for the day, students. We'll meet in next video. Thank you, students.